We're going to discuss what REST is in detail. So what does REST stand for? REST stands for representational state transfer. So uh, let's try to define what REST is now. So APIs that meet the REST architectural style constraints are considered to be RESTful. So here what we understand is that REST is a set of architectural uh, style constraints. So there are certain number of constraints, and if they follow if any application follows these constraints, then that application is said to be RESTful. So APIs that follow these given constraints of REST are said to be RESTful. So the constraints that are the guiding architectural constraints that are required for an API to be considered RESTful are as follows. The first constraint is that it should have a client server architecture. We know that most web architectures are generally client server architectures. The second constraint is that it should be stateless. That is, statelessness should be maintained. So what is stateless? What is statelessness? Basically, is that a server does not maintain information about a client once it processes a request and sends a response. So that's what statelessness means. The other four constraints are that it should have a layered system. There should be cacheability. There must be uniform design, and there must be code on demand. So let's go into depth of how these constraints are being satisfied. So when a client makes a request to a server for any kind of data, the response is sent. So the client in this case is typically going to be your application program, and you probably use some form of library to create a request from the server. So generally, when you're sending a request, you're sending it through the HTTP protocol, and the HTTP protocol in definition is stateless, meaning that uh, on the server side there won't be any state that is maintained of the client, or any information that is maintained of the client uh, throughout the HTTP protocol, throughout the sending and requesting of services and data. So if you want, uh, so the server won't remember anything about particular about the client. If you want to maintain state, like let's say login details, uh, you must send it with each and every request, and you'll be doing this using headers in the HTTP. So just like that, we checked off two of our constraints. So using the HTTP protocol satisfies statelessness, and our web architectures are client and server style architectures. So the next thing is that uh, what was the request that you were requesting? So let's say you want something. You have some e-commerce website open, and you're trying to buy a book. So when you open an e-commerce website, there'll be when you click on the website, basically the server will uh, respond to you by sending the homepage. So in the homepage, you'll have a list of books. Now let's say you go and click a book. So what you're doing is, when you click on the book, you're sending a request to the server requesting for the books resource. So on the homepage, there'll be a list of collection of new books. So each of these books is a resource, and when we click it, we take a closer look at the book resource. So let's say now we have received our response, and we have our book page, the particular book page, and then there's the author, number of pages, reviews for the book, etc. So if you click on the author again, now that's another resource. So when we click on the author, we'll be trying to access the author resource, and we'll see a collection of books that they've written. So your program sends a GET request to the URL, and the server responds with the data. And of course, all of the HTTP headers that you've come to know, and the body is typically represented as JSON, which is the JavaScript object notation.